Topic 5 was about drug analysis and identification. Now we're going to take a look at how drugs and alcohol interact, how they can with the body, how they can be collected from the body. A toxicologist works with bodies, and their job is to detect and identify the presence of drugs and poisons in body fluids, in body tissues, and body organs. They can work in crime labs and medical examiners' offices. Sometimes they work in hospital labs and health facilities to identify overdoses. Major branch of forensic toxicology deals with blood alcohol measurement. So we have a couple different pictures we're going to go through introducing that. The system, the circulatory system, and then a little bit about the lungs as well. Alcohol analysis gives a great example of what toxicology is. So again, it's detection and isolation of drugs in the body and determining how they influence human behavior. Alcohol, by definition, or ethyl alcohol, is a colorless liquid. It's normally diluted with water and consumed as a beverage. It's a depressant. It affects the central nervous system and, in particular, the brain. It appears in the blood within minutes after it's been taken by mouth. It'll slowly increase in concentration while it's being absorbed from the stomach and the small intestine into the bloodstream. When all the alcohol has been absorbed, a maximum alcohol level is reached in the blood, and the post-absorption period starts. After that, the alcohol concentration slowly decreases until a zero level is again reached. There are different factors that determine the rate at which alcohol is absorbed. Those include time taken to consume the drink, the alcohol content, the amount consumed, and food present in the stomach. Those all can affect alcohol absorption. So here we see just the difference between the alcohol absorption on a full stomach and on an empty stomach. So you see that on an empty stomach, the blood alcohol levels go way higher, and they stay higher for a longer period of time. Whereas if a person has a full stomach, that spike is a little bit lower, and it continues to be lower. The way alcohol is eliminated, there are two different ways: oxidation and excretion. So oxidation is the breakdown of alcohol in the liver, and then excretion is where alcohol is basically unchanged, and it comes out of the breath, comes out in urine, and it comes out in perspiration. The way a person is determined to be under the influence is either by measuring the quantity of alcohol in the blood system or in the breath. Experiments have shown that the amount of alcohol exhaled in the breath is in direct proportion to blood concentration. So it can be used to determine how much alcohol is in the blood. You can see here how to tell what your blood alcohol level is after drinking based on weight, based on amount of alcohol, and that'll give you your blood alcohol concentration. You have two different again versions of this graph or this chart based on empty stomach and full stomach. So how does blood alcohol content work? We have this closed circulatory system made of heart, arteries, veins, and capillaries. Alcohol is absorbed into the bloodstream from the stomach and from the small intestines. The blood carries alcohol to the liver, and that's where it's destroyed, broken down. Blood also carries the alcohol back to the heart, and it's pumped over to the lungs. Alcohol will leave with carbon dioxide, and oxygen enters the blood in air sacs known as alveoli. The carbon dioxide and the alcohol are exhaled, and the oxygen is inhaled. There are breath testers that are infrared. Here's infrared again. Infrared light absorption. They're becoming more and more popular in law enforcement. You can see a diagram here of how those work. Not that you need to know that necessarily, but definitely know that they are infrared. Many types of breath testers are designed to analyze a set volume of breath, and basically all you need to know again is that that breath is exposed to infrared light. It's the degree of interaction of the light with the alcohol that allows the instrument to measure blood alcohol concentration. At a traffic stop where a law enforcement officer is suspicious that a person is under the influence, there are field sobriety tests that are used to estimate a degree of physical impairment. There's a horizontal gaze nystagmus test, a walk and turn, and a one-leg stand. These are all reliable and effective, what they call psychophysical tests, to make sure what the level of impairment is by alcohol. Horizontal gaze nystagmus test is where an officer shines a light in a person's eyes and has them follow it out off to the side. Usually people will be able to follow it continuously out to 45 degrees. And then after 45 degrees, the eyes start kind of moving jerkily off to the side. The nystagmus is when the eye jerks, when the eyeball jerks. It doesn't move in a smooth motion. When a person's under the influence, that happens closer to the center than 45 degrees. After the field tests, then a roadside breath tester can be used to determine preliminary blood alcohol content. Back at the lab, gas chromatography is the most widely used approach for determining blood alcohol levels. You see a GCMS here in the diagram. When blood is drawn, kind of common sense, it's got to be medically accepted conditions, qualified individual. Its best preservation is when it's sealed in an airtight container, and anticoagulant is added and a preservative so that it doesn't spoil or clot. And then it should be stored in a refrigerator. If blood can't be collected, urine, brain tissue, or vitreous humor, the liquid from the eye, can be analyzed instead. Legal blood alcohol level has gone down throughout the years. Between 1939 and 1964, blood alcohol level was 0.15. In 1965, it was lowered to 0.1. And then in 1972, it was lowered to 0.8. That was adopted universally in 2003. All states adopted the 0.08. I guess it was in 72 it was recommended, it wasn't adopted until 03. I misspoke. So some people try to refuse to take a test for alcohol consumption. The National Highway Traffic Safety Administration recommended what is called an implied consent law. This was adopted in 1973 by all states, And what it says is that the operation of a vehicle on a public highway automatically carries with it the implied consent. A driver will submit for a test for alcohol if requested, or be subject to losing their license. Beyond alcohol, there's all kinds of different drugs and poisons that can be tested for. So the toxicologist is presented with body fluids or organs, and it's their job to examine them, again, to test for other drugs or poisons. Without supportive evidence, it's really difficult. Toxicologist has to know victim symptoms, a post-mortem pathological examination, which is an autopsy. Examination of the victim's personal effects can help. Without those, they're just kind of general screening procedures that would try to help narrow all the different drug and alcohol possibilities down to one, and poisons. The toxicologist isn't dealing with drugs at the concentration levels found in powders and pills, because after they've been ingested, they get kind of distributed throughout the body, and it's constantly, the drugs are being broken down. So it's a difficult process to try and identify what the original drug was that was taken into the body. If all of these obstacles have been jumped or hurdled, the toxicologist has to figure out whether the drug or poison is poisonous, is toxic, and how toxic it is. The scheme that the toxicologist has to come up with is a plan that will be able to detect, isolate, and identify toxic drug substances. Once the drug's been extracted from fluids, tissues, organs, then they can try to identify the drug that's present. Drug extraction is basically splitting drugs into being acidic or basic based on their pH. Some examples are here. Acidic drugs are barbiturates and aspirin. Basic drugs are meth and cocaine. So acid, if you remember, pH from 0 to 6.9. And bases are from 7.1 to 14. So again, like we talked about last topic, there's a two-step approach. There's screening and confirmation. The first screening step is done. It's kind of a more general thing. Positive results in this case we're classifying into acid or base. And then the confirmation test, the confirmatory test, comes later. So the screening step, the screening steps that are available for toxicology are thin layer chromatography, gas chromatography, and immunoassay. So know those three. And then GCMS, so pairing up the gas chromatograph with a mass spectrometer, is the best confirmation test, once again. To review, the GC separates the sample into its components. The mass spectrometer creates the fingerprint pattern that can be used for identification. The toxicologist has to provide an opinion on the drug's effect on an individual's performance or physical state. Might have to do that under oath.